In this video, you'll learn how to create motion graphs from verbal descriptions. The first thing to understand about how to do this is you need to know what is the direction that it's moving. So is it moving in the positive or the negative direction? Is it moving east or west? Is it moving to the right or left? In physics, rather than saying east or west or right or left, we typically will say in the positive or negative direction. Next, we need to know the speed. Is it moving? Is it at rest? Is it going at constant speed, speeding up, or is it slowing down? So let's take a look at some examples. We'll start with an example of an object that's not moving. So if it's not moving on the position graph, it's just going to be a horizontal line. The velocity will be 0, and the acceleration is 0 because the acceleration has to do with the change in velocity over time. Next, we'll look at constant speed in the positive direction. So it's going to be a straight line diagonally. Velocity will be a horizontal line at whatever velocity is traveling, and it's not changing. So once again, the acceleration is going to be 0. Next, we'll look at constant speed in the negative direction. And this is going to be a straight line, but it's a diagonal. Now, when we say negative direction, sometimes students think that, oh, it's not going very fast. But really, the negative is just talking about the direction that it's moving. So for example, the positive direction could be, maybe it's in the east. We might say east is the positive direction. And the negative could be the west. And so going west is not any slower than going east. It's just a direction. On the velocity graph, it's going to look like this. It's a horizontal line because the velocity isn't changing. And so since the velocity is not changing, the acceleration is going to be 0. Now let's take a look at a situation where the object is speeding up in the positive direction. So the graph here on the position graph is going to be it's going to be curved. And what you're going to notice is that it starts off flat, and then it becomes steep. And the steepness of the graph on the position graph tells us how fast it's going. So this is getting faster. So the velocity is going to look like this. It's an increasing speed, but in the positive direction. And the acceleration, because on the velocity graph is a straight line, the slope on a velocity graph represents the acceleration. It's just going to be a horizontal line. Next, we'll take a look at speeding up in the negative direction. So now we're going to go from flat to steep. So it's going to go from flat to steep, but it's going to be going towards the origin. So I got flat, and then here we have steep. Okay. Now on the velocity graph, it's going to start here, and it's going to go faster and faster. But notice now it's going in the negative direction. It's still going faster, but it's going to go in the negative, speeding up in the negative direction. This slope is negative slope, so the acceleration is going to be negative. Okay, so let's take a look at these two situations a little bit, because students often have a hard time with this. I'm going to just draw on when it's speeding up. I'm going to draw the direction of velocity. So direction of the velocity is to the right, and the direction of the acceleration, I'm going to say right is positive, and the direction of the acceleration is also going to be to the right because it's speeding up. So its velocity is to the right, it's going in the positive direction, and it's speeding up. So the acceleration will be in the same direction. Okay, now in the next one, the object is going in the negative direction. I'm going to say left is negative, okay? And it is also speeding up. So because the velocity is to the left and it's speeding up, the acceleration will be in that same direction. So one thing you notice is that when the velocity and acceleration are in the same direction, the object is going to be speeding up. Next, let's take a look at what happens if it's slowing down. So if it's slowing down, it's going to go from steep to flat. So steep to flat. Okay, so this is steep, and over here it's flat. Okay, so it's in the positive direction. So I'm going to stay above the t-axis, the t-axis right there, so it's positive velocity, but it's slowing down. Now you notice this is a negative slope, and so the acceleration here will be negative. Okay, so let's think about this. Let's see if this makes sense. The object is moving in the positive direction, and the object is slowing down, so I know the acceleration has to be in the, let me fix that, positive direction, and so I know the acceleration has to be towards the left. So take a look at the velocity and acceleration direction. Notice how they're in opposite directions. When they're in opposite direction, the object will be slowing down. Let's take a look at slowing down in the negative direction. And here we're once again going to go steep and then flat. So we're going to go steep and then flat. So steep and then flat. Okay, so it's steep and then flat, and it's going to be a negative velocity, and then flat means that it's coming to a stop there. And so this is a positive slope, so the acceleration here is going to be positive. Let's see if this makes sense as far as thinking about the direction of the velocity and speeding up in the acceleration. Okay, so this object is going in the negative direction. So I'm going to put my arrow to the left here. Okay, so the arrow is to the left, and that's my velocity. And then the acceleration is going to be to the right, okay, because it's going to the left, but it's slowing down, so the acceleration is going to be the right. If the acceleration were to the left, this object would be speeding up. Okay, so kind of recap a little bit here. So when the velocity and acceleration are in opposite direction, the object will be slowing down. Okay, and hopefully that helps you to think about what the acceleration graph will look like. When the velocity and the acceleration are in the same direction, then the object is speeding up there. Okay, and the other thing I want to emphasize here with these is that the direction, right? So the direction, whether it's positive or negative, it's just telling you the direction. It's not saying that the velocity is less because it's negative. It's just telling us about the direction.